So today we have a few more identities to add to our toolbox here. We've got the sum and difference identities, where we have two different angles added or subtracted inside, sine or cosine. These exist for tangent as well, but the sine and cosine ones are really all you need to know. And then we've got double angle identities, where you've got sine or cosine of 2x. These actually just come from the sum identities, because 2x is just x plus x. So for a sine, for example, sine of 2x is the same thing as sine of x plus x. And so then if you write this out here, the way I remember these, by the way, is that for sine, the plus or minus is the same. So for sine, if it starts with plus, then it's still going to be plus. If it starts with minus, it'll still be minus. But then the functions are mixed up. Sine and cosine are next to each other. So sine, the sine is the same. So then cosine, the sine, the plus or minus, is different. But then the functions are the same together. It helps me, may or not help you. But see, here's sine. The sine is the same. So if it started with a plus, it's going to stay plus. And we'll have sine and cosine mixed together. And then over here, we'll have sine of the other x, and then cosine of that x there. And so right here, that cosine and that sine multiplication is commutative. You can switch the order either way. And so you have two of the same thing. You have two of these, so you have two of them. So that's where that identity comes from. So one way we might use these is we might simplify some things. So we can take this and write out that identity. So the sine is the same, cosine it's different. So if it started with a minus, it's going to be a plus over here. But the functions are going to be the same ones together. So it's going to be cosine and cosine together. And then it's going to switch to sine. And so then the key thing right here is it looks like just a whole bunch of letters, a whole bunch of symbols, and some Greek letters here. The key is to notice the difference between theta and pi, where theta is a variable, but pi is an angle, or pi over 2 here. So these first ones are numbers that we can find here. That's the difference, to see the difference between these two things here. That's the key. So we're looking at the angle pi over 2. Pi over 2 is straight up on the unit circle. So we're looking at the point 0, 1. So the cosine, the x, is 0. 0 times cosine theta. That part's a variable. We can't do anything with that. And then sine, the y-coordinate is 1 times sine theta. Then, of course, 0 times anything is just 0, so that all goes away. And then 1 times anything doesn't do anything. So we've just got sine of theta as our final answer. Another thing that we might do with these is solve equations. So if you look at this equation here, you just kind of want that sine of 2 theta to pop out at you as, hey, there's an identity for that. You know something for that. So we're going to place sine of 2 theta with the identity there. So we're going to have 2 sine theta cosine theta plus cosine theta equals 0. And then again, the name of the game for solving equations, the number one thing you're going to do is equal to 0 and factor. So we've got a GCF there that will factor out. Be left with 2 sine theta plus 1. And then we've got our 0 product property. Either cosine is 0 or 2 sine plus 1 is 0. So if you subtract the 1, divide by the 2, you'll have sine of theta equals negative a half. So then here we want the x-coordinate on the unit circle to be 0. So we're looking to be on the y-axis, either straight up or straight down. So our two options here are pi over 2 and 3 pi over 2. And then the question would be, do I need to add plus 2 pi n there? If it just said solve or find all solutions or the general solution, you'd have to have those infinite number of answers, that plus 2 pi n. But we restricted you here. We only wanted solutions between 0 and 2 pi. So these are the only solutions over that error. And then sine being negative a half, we're going to have to look at ASTC. All students take calculus. For sine to be negative, that's going to be the third and the fourth quadrant. And of course, we also have to think about our unit circle memorization. We know that sine being a half, a y-coordinate being a half, that's pi over 6 angles. So it'll be some sort of pi over 6 angles. And then again, if it takes you a minute to figure these out, that's okay. But in the third quadrant, a pi over 6 angle will be 7 pi over 6, a little bit more than 6 pi over 6, a little bit more than 1 pi. And then in the fourth quadrant, pi over 6 angle we want, that'll be 11 pi over 6, a little bit less than 2 pi, a little bit less than 12 pi over 6. And so there are our 4 solutions over 0 to 2 pi. And then for this one, cosine 2x, again, we got to think there's an identity for that. We know an identity for cosine 2x. There are a few different options for cosine 2x. So there's a couple of different ways you can approach this. One way is to just always use this first one here, cosine squared minus sine squared. If you just want to use one, you can always work with that. I'll talk in a minute about how you could have chosen one of the other ones. But let's just say if we always want to do cosine squared minus sine squared, well, we'll have cosine squared x minus sine squared x plus sine x equals 0. Well, having these different trig functions here without a GCF, there's no way we're going to be able to do with that as it is. So we want to replace that with either all sines or all cosines. Well, since this sine doesn't have a squared on it, there's no way we're going to replace that sign. The way we replace these is those Pythagorean identities, meaning that sine squared plus cosine squared equals 1. It's only true if it has the square on it. So I can't replace the sines. I've got to replace one of these. Well, if I'm always going to have that sign there, I want to make the cosine go away. So if I look at this, cosine squared is going to be 1 minus sine squared. So I've got 1 minus sine squared x minus sine squared x plus sine x equals 0. And then I've got some like terms right here. I've got 2 of those. So I have 2 of them. The 2 of them. And so this is where you might now see that you could have actually jumped to that step right there. You could have skipped these couple steps if you knew that there was this other identity for cosine 2x, if you had all 3 of those options available to you. Well, you could have looked at this and said, all right, I've got that sign right there, so it'd be more helpful if I replaced cosine 2x with something that only had sine in it, not something that had cosine in it. So if I was choosing one of those 3, I would choose the one that just had sine in it. And so I could have gone right to replacing cosine 2x with 1 minus 2 sine squared. It's your choice how you'd like to do it. Once I've got that, that's going to be a quadratic type pattern. And so I like to keep my squared term positive, so I'm going to put everything on the right side. I think if the squared term is positive, that makes things easier to factor. So we move everything over the right side there, add the 2 sine squared, subtract sine, subtract 1. And so this is where you could do a u substitution, if you like. If you wanted to, you could do 2u squared minus u minus 1. If you like to do those u substitutions. I'm going to try to just go ahead and factor it. So if I wanted to just factor it, well, instead of just x and x or u and u, I need sine and sine to get me sine squared. I'll need a 2 there. So I'll have 2 sine x and sine x. 2 sine x times sine x gives me 2 sine squared. And I've got to multiply to -1, so it's got to be 1 and 1. So I'm going to have 2 sine x and 1 sine x. Well, to get -1 sine x, I want -2 sine x's and plus 1 sine x. And you can do the u substitution though there if you prefer. So I can do my 0 product property. And I've got these 2 options here. This part we've already seen. That's the same as this last one here. That was the 7 pi over 6 and the 11 pi over 6. And then over here we want sine to be 1. So this time on the unit circle, we only want the angle that's straight up. Straight down, the sign would be negative. So just to have positive 1, I only want pi over 2 for that branch. And so this one, I just get 3 solutions there. So just look to use those identities anytime you see these things with a 2 inside the trig function or a plus or minus inside. Just go right to substituting these identities right here and work it out.